Okay, so for today's lecture, so before that, yesterday we have learned about some basic, or introduction to root locus. So for today, we will learn more into how to sketch root locus by using several rules provided in this lecture. Okay, so for those who haven't learned about lecture from yesterday, maybe for today it will be slightly harder for you, but I think you will doing well, so don't worry so much. So for today's lecture, we will go into lecture 4B about refining root locus sketch. Okay, so students will be able to apply additional rules for refining root locus sketch by finding the real axis breakaway and breaking points, finding the JW axis crossing, and finding the angle of arrival and departure. Okay, so we will go into learning about the rules, and then after that we will learn about these three additional rules. Okay. Okay, so a little bit of review about what is root locus. So basically, root locus is the path of the roots of the characteristic equation or the denominator of a transfer function in S-plane as a system parameter is changed. So let's say you are given a transfer function in this system. Okay, so we have gain k here, and we have transfer function g and h. So we know that we can determine the stability of a system by finding the poles of the closed loop transfer function. And we have learned in Raut-Hurwitz criterion that we can determine the number of poles and stability by using table method. Okay. And we also know how to find the gain k, the range of gain k for stability of the system. But for root locus, the difference is that when you have gain k, then when you vary the values of k given, let's say you varies from 0 to infinity, then the poles of the transfer function will change according to the gain k. So how the value of poles change with gain k can be represented by using root locus. Okay, so before you try to draw the or sketch the root locus, so you need to simplify the block diagram given here. Okay, so to simplify this, you know that these two are in series or cascade, and H is feedback with these two. So you can simplify this. G divided by 1 plus KGH. Okay, so G divided by 1 plus K times G times H. Oh yes, it's actually kg, okay? So miss kg here. And then when you simplify, you will get the denominator. So we take only the denominator here. So the denominator now is in terms of k. So to factorize this in terms of k is difficult if you don't know what is the value of k. Meaning that when you change value of k, then the value of the poles will be different. So this is your denominator just now. So when you simplify, you will get something like this. And then you can find the roots or the poles of the characteristic equation or denominator when k equals 0 and when k equals infinity. So the root locus basically plots the poles when you change the value of k from 0 to infinity. So the root locus will start at k equals 0 and then will end at k equals infinity. So the first thing you need to do is to determine the poles when k equals 0. and then the poles when k equals infinity. Okay, so when k equals 0, so this term here will be negligible. Okay, will become 0. So you only have these three terms here: s plus 2, s plus 4, and s plus 5. So you equate this with 0, and you will get the poles will be -2, -4, and -5. So there are three poles at k equals 0. Okay, so now you find the value of poles when k equals infinity. So when k equals infinity, this value here will be very large compared to this. So you can ignore these three values, and you only take these two values here. So you will get the poles will be s equals -1 and s equals -3. Okay, so you have two poles, -1 and -3, and we add one more poles because we know that at k equals 0 has three poles. So at k equals infinity, we found only two poles. So we need to add one more pole so that k at infinity has the same number of poles as k equals 0. So we add one more, p3 equals infinity. So when you have three poles, for example, -1, -2, -4, and -5, and at k equals infinity, you have -1 and -3 only. So you add one more or additional poles, but it equals to infinity. Okay, so I will go through the rules, and we will look at one of example how to do the root locus, and then after that you will do your quiz. Okay. Okay.
Doktor,
Yep.
kenapa kita neglect S plus 4, S plus 5, S plus 2 untuk infinity?
Okay, sebab bila infinity, value ni jadi sangat besar. Value yang kat sini sangat besar berbanding yang 3 ni. So kiranya yang ni 3 ni sangat kecil lah, macam almost 0. So we only find the roots for s equals -1 and s equals -3.
Okay, noted.
Okay. All right, so we look at the rules first. Okay, so the rule number 1 for sketching the root locus is that the number of branches of the root locus is equals to the number of closed loop poles. So, for example, in this example that I showed just now, you found three poles: -2, -4, and -5. So you have to expect that the root locus will have three branches, okay, or three garisan, or three lines, or three graph. So for example, like this is example from yesterday. So yesterday we found two poles. First it's at -10, and another one is at 0. So you have two poles, meaning that you have to expect that there are two branches for the root locus. So the first branch is starting from here and going up, and then another one is starting from -10 and going down. Okay, so the number of branches equals to the number of poles. Okay. Rule number 2 will be the root locus is always symmetry about the real axis. So same example. So if you look at this, the root locus is symmetry about the x-axis or real axis. So you cannot draw the root locus. Maybe you go up here, and then here you go up as well. You don't go down. So you need to remember that this is the root locus must be symmetry. So if one of the branch go up, then another branch will go down. Okay. So you need to remember that it's symmetry. So symmetry because you know that some of the poles that you calculate will be in terms of complex number. So complex number meaning that, for example, here you have 5j. Okay, so you know that complex number has conjugate. Conjugate means that, for example, so let's say you have s equals 1 plus j. So let's say this is one of the pole. So if you plot in the S-plane, it will be somewhere. Okay, so put minus here. So somewhere here. So you know that complex number has conjugate. Conjugate meaning that, so you can expect that another poles will be -1 and -j. So these two are conjugate. Okay. Okay, abaikan tulisan yang buruk. Okay, conjugate. So if you plot, it will be somewhere here. So these two will be symmetry about the x-axis, okay, or the real axis. So symmetry because of conjugate, okay. All right, and then rule number 3. So rule number 3 is slightly harder to explain, but usually I will ignore rule number 3. So what rule number 3 says is that on the real axis, for k bigger than 0, the root locus exists to the left of an odd number of real axis finite pole or finite open loop zeros. Saya tak tahu nak explain macam mana. Benda ni selalunya saya ignore sebab tak penting sangat. So yang saya faham based on my understanding is that the root locus will try to you have to sketch the root locus starting from maybe starting from poles, and then it will go to the left. Okay, so always moving the root locus to the left before going to the right. That's what is my understanding. But if you read from books, the explanation is different. Maybe they do some derivation or something, but usually for this rule, I simplify it further by saying that root locus will go to left. So when you sketch root locus, you will always start by sketching it to the left. If you cannot, then you will go to the right. Okay, meaning that you will always start it going to the left. If you cannot go to the left, then you go to the right. Okay, don't worry, later we will see example. Okay, rule number 4 is that the root locus begins at poles and ends at zeros. So the example that I showed earlier, I show you how to determine the poles. Okay. So what actually happened is that if you go back to this, if you go back to this transfer function, if you look closely, when k equals 0, you will get these 3 as the poles, meaning that the poles, you have to look at the denominator here. And when k equals infinity, you will get these 2 as the poles. And if you look at this transfer function above here, these 2 values here, or these 2 poles here, actually indicated to these 2 values, or this is known as zeros. Okay, and these 3 the bottom in the denominator is the poles. So what I'm trying to say is that when k at equals 0, so k equals 0, you will get the poles. And when k at infinity, you will get the zeros. So instead of substituting 0 and infinity into the k, what you can do is find the poles of this trans function here. Then you get the value of poles at k equals 0. And then you find the zeros. And then you will get the value of poles when k equals infinity. Okay? So you have to find poles and zeros for root locus. Okay, and your root locus will always start at poles and ends at zeros. So for example, so let's say you have poles at -1, -2, and then your 0 is at -3 and -4. So when you sketch your root locus, you need to know that your root locus will start at poles, and then somehow it will travel, or you will sketch it such that it will go back to the zeros. Okay. So if you look at the arrow indicates that it starts from poles and then goes to the 0. Okay. So you must wonder why you get circle. I will explain this maybe later or next week. Okay. Why root locus is circle. But now you need to understand that the root locus starts at the poles and ends at zeros. Okay, that's the rule number 4. And rule number 5, the root locus approaches a straight line. So this straight line, we call it asymptotes as the root locus approaches infinity. And the asymptotes can be calculated by using this formula. So you have two formula for asymptote. So the first formula is the real axis intercept. So real axis intercept equals the sum of poles minus the sum of zeros divided by the numbers of poles minus the numbers of zeros. So when you calculate this, you will get the real axis intercept. Okay. And then the second formula is the intercept angle. So what angle of the root locus of the asymptotes? So to calculate the angle, theta A equals 2k plus 1 pi divided by the number of poles minus the number of zeros. Okay, let's look at an example how to calculate the asymptotes. Okay, so let's say you are given this system. So the first step you need to do is to you can either simplify the system or you can find the poles and zeros. So for unity feedback, so this is unity feedback. Unity feedback meaning that your feedback transfer function h equals 1. Okay, so for unity feedback, the feedback transfer function h equals 1. So for this unity feedback system, you can straight away find the poles and zero. But for feedback that has different transfer function, you need to simplify the system first and then look at the denominator. Okay. So for this case, you know that the poles will be 0, s equals 0, -1, -2, and -4. So these are the poles. And then the zeros will be -3, -3. And because you have 4 poles, and your zero must also have 4 as well. So you get 1 0 only. Here is -3. So the remaining 3 zeros will be infinity. Okay. So you have one zeros at -3, and the remaining 3 zeros will be at infinity. So you try to equates the number of zero and poles that you found. Okay. So let's say you found more zeros, then your poles will you need to add infinity to your poles so that the number of poles equals the number of zeros. Okay, so first step to calculate asymptote is to calculate the real axis intercept. Okay, so the sum of finite poles minus sum of finite zeros divided by the number of finite poles minus the number of finite zeros. So finite poles will be -1 plus -2 plus -4 and plus 0. And finite zero, so you only consider this zero only, even though you get 3 infinity. But since this is finite zero, meaning that zero that can be found directly from the transfer function. So you only consider that in calculation. So here minus 3. So you divide it by 4 poles. So you have 4 poles here, and you have only one finite zero, which is only -3. So divided by 4 minus 1. So you get -4 divided by 3. And you can plot this on the S-plane. So it will be somewhere around here. Okay. -4 over 3. So it will be somewhere around here. And then after that, you need to find the asymptote angles. So the asymptote angles will be 2k plus 1 pi divided by the number of finite poles minus the number of finite zero. So how to determine the k here? So first, you assume k equals 0. So when you assume k equals 0, you will get pi over 3. So the first angle is pi over 3. Next, you assume k equals 1. When you substitute k equals 1, you will get theta a equals pi. And then you assume k equals 2. Then you will get theta a equals 5 pi over 3. And then when you assume k equals 3, you will get theta a equals 677 over 3 pi. So what you need to do is that when your theta a is bigger than 2 pi, then you need to stop calculating for theta a, meaning that k equals 3 is not the values you are looking for. Okay, so you stop calculating theta a when your theta a becomes bigger than 2 pi. Okay, so you only try to calculate theta a for angles below than 2 pi. Okay, and then after that you try to sketch the asymptote line in the S-plane. So the first line is at pi over 3. So here is pi over 3. And then the next line is at pi. So the next line here, it's equals pi. So basically, the third asymptote, the second asymptote is on the real axis. So the first asymptote is on this line. Okay. And then the third asymptote will be at 5 pi over 3. So 5 pi over 3 will be this angle. Okay. And then the third asymptote is here. Okay, mungkin padam kot pening dah. Okay, so the first asymptote is pi over 3, this line. The second asymptote is pi, the angle pi, which is this line here. And then the third asymptote is 5 pi over 3, another line here. So this line will start at the intersection sigma A just now. Okay. So when you found sigma A, which is negative 4 over 3, so the asymptote will start from the interception and then follow the angle you found by calculating theta A. Okay, pening, tapi we will see one example later how to determine the asymptote. Okay, but for now you need to know that there are two formula for asymptotes. The first one is sigma A, and the second one is theta A. And then this asymptote will be the line where your root locus will never cross. Okay, so if you look at this blue line here, so when the answer sketch the root locus, so the root locus here will extend and will not intercept the asymptote. Okay, same goes to the bottom one. Okay, but it will reach reach the asymptote at infinity. Okay, but it will never cross the asymptote. Okay, so the asymptote will allows you to know what the root locus will be look like. Okay, when you sketch it later. Okay, so these three lines here are the asymptotes. Okay, so if you look at the asymptote on the real axis, so basically, usually, generally, the asymptote at real axis is not considered as something like it's not considered as an asymptote, meaning that the root locus will cross the real axis. Okay, for example, this blue line here, if you see here, and this blue line here. So this blue line here, even though it's on the even though it's on the real axis and crosses the asymptote, but it's okay. Okay, but these two lines here, you can the root locus cannot cross it. Okay. Okay, tak apa, kita tengok more rules. So just now it's rule number 5. Good. Okay, so there are 3 more rules: JW axis crossing, real axis breakaway and breaking points, and angle of departure and arrival. So what are these? So the first additional rules is JW axis crossing. So basically it's this intersection or this crossing here. So how to calculate the crossing at the JW axis? So the root locus will cross the JW axis, but how to calculate this? So to calculate this, basically the JW axis crossing, basically when the root locus cross JW axis, meaning that the system will transit, okay, from stable to unstable. So you know already that stable system lies on left hand side. Okay, the poles of the stable system lies on the left hand side of the S plane. And then unstable system will be when the poles lies on the right hand side. Okay. And then on the real axis, on the JW axis, the system is marginally stable. Okay. So on the JW axis, the system is marginally stable. Okay, so to know about the JW axis crossing, basically you want to know what are the value of K or the value of poles for the system to be marginally stable. Okay. So let's look at an example how to find JW axis crossing. Okay. So for finding JW axis crossing, you need to use Route-Hurwitz criterion. Okay. So the first step on using Route-Hurwitz criterion is, of course, you need to simplify the block diagram given here. So simplify the block diagram and then find the transfer function and then simplify the denominator. Okay, because Route-Hurwitz criterion requires you to use the denominator. Okay, so here the denominator is given, okay, given here. So from the denominator, you draw the Rauter-Hurwitz table. So you start with s power of 4, and then followed by s cubed, and then you fill the two top rows alternatingly. Okay, so 1, 7, 14, 8 plus k, 3k. And then you find S2 using determinant, okay? So you get 90 minus k, and here 21k. Same for S power of 1 and S power of 0. Okay, so you use determinant. Okay, and then you need to determine the value of k at JW axis crossing. So pure imaginary roots only exist when there is 0 row. Okay, so you need to find the row such that it becomes 0. So here only row S1 that can become 0, okay? Because this is already 0 and this is already 0. So you can only alter this value so that this becomes 0, meaning that you need to find the value of k such that this value equals 0. So you start with S1. Okay. So from here, you can equate this equals 0, and then you will get k equals 9.65. So here there is another value of k. So if you use calculator, you get matrix pula ni. Okay, kita rosak. Okay, so minus 1, minus 65, 720. So you get 9.65, and another one is minus 74.65. So you get two value of k. So here you only take positive k, okay? You only take this one, so you ignore this k, negative 74. You only take positive value of k. After that, you calculate for the value of frequency, okay? So when you find k at S1, you take the value and substitute into row S2. So this is from row S2. So what you have to do is you substitute k equals 9.6 into each of this, and then you write this in terms of a new polynomial. So here you take 90 minus k times s squared plus 21k times s power of 0. Okay. So if you still remember about your Rauter-Hurwitz method for finding the values of k, or values of the row when all of the rows become 0. So you need to use one row above, okay? So it's something like that. So you substitute this into row s squared, substitute k, and then you'll get 80.35 s squared plus 202.7 equals 0. And then solve for s, find value of s. So you will get s equals plus minus 1.59 times j. Okay, so the system is stable from 0 until k 9.65. And at k equals 9.65, the system is marginally stable and oscillating at frequency 9.65 radian per second. So this frequency, so this is not the frequency. So the frequency is here, okay? 1.59 radian per second. So ni salah ni. So this is the frequency, we call it damping frequency. Or the frequency of the system at marginally stable. Okay, so you know that marginally stable system is a system where it will keep oscillating until infinity time. Okay, meaning that it will not stop or it will not increase in terms of the values. It will keep oscillating. So what is the frequency of the oscillation? It's this value. Okay, this is the value of the oscillation or the frequency of the oscillation. So to find the JW axis crossing, you need to use Raut-Hurwitz table, and then find the value, find the rows such that the rows will have all of the values as 0, and then use that K on the row above, and then find the value of frequency. So the frequency here is the JW axis crossing. Okay? So if you plot this point on your root locus, it will be here. So this is the crossing or the JW axis crossing where your root locus will cross. Okay, so your root locus, if you sketch later, it will cross here at this point. So it cannot cross other point. Okay, it will cross at the JW axis crossing. Okay, banyak sangat dah. We look at another rules, which is the real axis breakaway and break-in points. So if you look at this root locus starts at real axis and then suddenly break away, okay? Break away from the real axis, and then it will break in back into the real axis. So this point here is called the breakaway point. This is breakaway, and this is break-in point. Okay. So you need to know at which point this root locus will break away and break in, so that when you sketch the root locus later, you know that it will the circle will start at this point, but not this point, or not this point, but at the breakaway and break-in points. So how to find breakaway and break-in points? So here the breakaway and break-in points is indicated here, and the angle is 90 degree. So it will break 90 degree, okay? So 90 degree. So the formula to calculate this is angle is always 90 degree, okay? So the formula to calculate the breakaway and break-in points. Okay, so basically breakaway points is the point where maximum K occur, and break-in point is the point where minimum K occur. Okay, ni abai kan? So the formula to calculate breakaway and break-in points is, there are two methods. First is differentiation method, and the second is transition method. So we're going to use transition method. So if you are hardworking enough, macam nak tahu lebih, so you can go into using differentiation method. Okay. So the transition method basically is this formula. So the formula is the sum of 1 over sigma minus zeros. So this is zeros equals summation of 1 over sigma minus poles. So sigma here is your breakaway and breaking points, okay? So if you have, let's say, three zeros, so what you need to do is you have to do 1 over sigma minus the first zero plus 1 over sigma minus the second zero plus 1 over sigma minus the third zero, and then equals, let's say you have two poles, so 1 over sigma minus the first pole plus 1 over sigma minus the second pole. And then you simplify the equation to find sigma. Okay, let's look at example how to use this method. So from this root locus, so the x represent the zeros, the poles, okay, and the circle represent the zeros. So here you know that the poles is -1 and -2, and the zeros are 3 and 5. So using the formula, the summation of 1 over sigma minus 0 plus the summation of 1 over sigma minus pole. So the first one is 1 over sigma minus 3. So the first zero is 3 plus 1 over sigma minus 5 equals 1 over sigma minus 1. So becomes plus 1 plus 1 over sigma minus 2. So becomes plus 2. And then you rearrange and simplify. You will get quadratic equation here. And use calculator to get the first sigma is negative 1.45. And the second sigma is 3.82. So if you sketch or if you plot these values, so the first sigma is somewhere around here. And the second sigma is somewhere here. So these two are the breakaway and breaking points. Ada soalan nak tanya?
Kenapa kita ambil sigma minus 5? Kenapa kita tak ambil minus 4 ke?
Oh, sebab kat sini ni dia punya zeros, okay? Ni zeros kita. Ni zeros kita. So X dengan X ni represent poles. So X are poles and circle are zeros, okay? So usually we represent poles as cross or X and zeros as the circle, okay? So dekat sini ada dua je zeros, 3 and 5, and dua poles, -2 and -1.
Betul.
Okay. So sama macam case interception tadi, kita ambil finite poles and finite zero saja. So kalau ada infinity, yang tu tak kira, okay? Okay. Tak apa, kita akan tengok example nanti. Okay, so the last rule is the angles of departure and arrival. So the angle of departure and arrival is only for complex poles and zeros, okay? So let's say when you calculate poles and zeros later, you get a complex number, complex poles and zeros. So complex poles, you will have angle of departure, and complex zeros, you have the angle of arrival. So the formula is here. So the angle of departure equals 180 plus the angle of zero minus the angle of poles, and the angle of arrival equals 180 minus angle of zero plus angle of poles. So how to find angle of zeros and angle of poles? Uh, Complicated sikit. Tapi saya cuba explain lah. Okay, so let's say you have, for example, you have poles here. Okay, let's say you have poles here, x, and then you have two more poles, one here, and three more zeros, one here, and here. So the rules for angle of departure and arrival applies only for complex poles and zero. So this pole here has no angle of departure or arrival. Same for these zeros. There is no angle of arrival for this zero. So these two uh, pole and zero has no angle of departure and arrival.
Because because
Hmm?
because
So because angle of arrival and departure only for poles and zero, that is complex number. So dua ni dekat real axis. Tak, maksudnya complex number dia zero. Kat sini zero kan. So maksudnya dia tak ada J, tak ada complex part. Dia hanya ada real part only. No imaginary part. Okay. Tetapi dekat X ni dengan bulatan ni dia terletak dekat bukan pada real axis, meaning that it has imaginary part and also real axis part. So when you have poles and zeros that has real and imaginary part, then it should have departure and arrival angle. Tak apa, kita tengok nanti korang buat quiz faham kot. Tak faham kita tengok lagi. Okay, so we look at this X here. So to find the angle, sekejap dia measure apa ni. Okay, kita tengok yang ni senang sikit. So to find the angle mana ni? Alah, example tak best. Okay, so let's say your pole is somewhere at this point, okay? So assume that this point is your pole, okay? So to find the angle theta p, so we call it theta p1. Let's say this is point p1. So to find the angle p1, first we calculate the angle from all zero and poles, meaning that the lines from zero and poles that intersect with this P1. So first, let's say from this X, we create a line that intersect from this point, that connects this point and P1. And then we find this angle. So we get theta 1. And then the next one is, sekejap macam tu kah? Lupa dah cara dia. Betul lah. Okay, so and then the next one is maybe this zero, and then you connect the 2 points by a line, and then you determine the angle. Same for the other poles and zeros. And then for this P1 P1 poles, the angle is 180 plus all the angles of zeros, meaning that theta 2, theta 3, and theta 6. So you find theta 2 plus theta 3 plus theta 6, and then minus all the angle measured from the poles. Okay, so theta 1, theta 4, and theta 5. So theta 1 minus theta 4 minus theta 5. Okay, so this is only for this pole. So to find the value of angle at, let's say, at this pole, so what you need to do is you create a line connects these 2 points, and then these 2 points, and then you find the angle. Okay, angle measured from real axis. Okay, so ada banyak kerja lah kena kira kat sini. Tak apa, kita tengok example nanti. Okay, saya tahu awak pening lalat, tapi kita tengok example lah. Okay, so let's say you are given a system with this transfer function. Okay, unity feedback. So find the angle of departure from the complex poles. Okay, so complex poles. So here the open loop poles is -3, and here you cannot factorize using by hand, so you need to use calculator, and you get -1 plus j and -1 minus j. So these two poles here are complex number. Okay, so complex number meaning that you have to expect that it has angle of departure. Okay, kalau poles, angle of departure. Kalau complex 0, angle of arrival. Okay, so there are one finite 0, -2, and 2 infinity, because there are 3 poles, so you need to add 2 more zeros so that the 2 has the same number. Okay, so the 2 more zeros and infinity. Okay, so soalan ni basically the sketch root locus. Okay, so first rule, we know that since we have 3 poles, so we must have 3 branch. Okay, so rule number 1 says that the number of branch equals the number of poles or number of zeros, whichever that has many. Okay, so here we have 3 poles and 1 0. So 3 poles meaning that there are 3 branches. Okay, so that's the first rule. And second rule, the root locus must be symmetry about real axis. So masa nak sketch nanti, make sure the symmetry about real axis. And rule number 3, start from odd poles or 0 to the left. Okay, so rule yang saya kata saya tak faham ni, maksudnya dia start to the left. Okay, before going to the right. And rule number 4 says that the root locus must start from pole to 0. So the root locus must start from poles and ends at 0. Okay, so first step is you sketch the poles and zeros on the S-plane. So here is your poles. So poles just now is -3 and -1 plus minus j. So -3 and -1 plus j and minus j. So you have 3 poles here. And the second thing you need to plot is the 0. Okay, 0 is at -2. So you use circle for 0 and X for poles. Okay, and then after that, you need to determine the angle of departure because you have complex poles. So here you need to determine the angle theta 1 and the angle theta 2. Here sebenarnya sini, theta 2. So how to determine the angle? So first, kita keluarkan yang poles dan zero saja. So to determine theta here, first you need to draw lines that connects the poles and zeros to the poles that you are trying to calculate the angle. So kita nak kira angle sini. So we want to calculate the angle of this pole. So first you connect the lines from this pole to this pole, from this 0 to this 0, and from this pole to this pole. And then you determine the angle of each of the lines. So this line is 90 degree. This line here, so you need to use tangent ke, cosine ke, sine, depending on trigo lah, okay? Trigo. So this is theta 2 is tangent minus 1, opposite aside. So opposite 1 over 1. Okay, yang ni panjang dia 1. So 1 over 1. 45 degree, right? And then theta 3, you use trigo juga. So theta 3 is tangent minus 1. So opposite aside. So aside panjang ni 2. Okay. And then you use the formula, okay? So the formula is theta equals 180. Lain tak formula dia? Okay. Minus theta P plus theta Z. So theta P is 90 degree just now. Minus theta 3 is tangent 1/2. And then plus tangent theta 40, which is theta 2, is tangent minus 1, 1 over 1. And then minus 180 degree. Okay, kalau guna minus, you akan dapat negative angle. So negative angle basically they measure dari bawah ni ke sini, okay? But if you use plus positive 180, you will get this angle, okay? Yang angle theta ni. So sama je, okay? So this is the value for theta. Masya Allah, banyaknya calculation. Okay, and then when you get the angle theta here, and now you know that this angle will be the same, okay? The angle for these poles. Ni pun theta juga, sebab dia symmetry, okay? So when you get this theta, you know this angle as well because of symmetry. So you tak perlulah cari angle ni and cari angle ni pula. So cari satu je, dan bawah ni sama dengan atas sebab dia symmetry. So kalau ada X lagi kat sini, let's say kat sini dengan sini, so you only need to find one angle only. When you find this angle also the same with the one above because of symmetry, okay? Okay, so okay, so kita rehat sebentar 5 minit ke 10 minit. And then we look at your quiz number 2 and we try to do question 1. Quiz number 12, we try to do question number 1, okay? Okay, kita rehat 5 minit. Start balik 11 suku lah.
Agak susah lah tu.
Memang susah pun. Soalan root locus ni famous untuk student tak jawab. Mostly tak jawab lah sebab dia orang dah pening.
Sebenarnya berapa markah sudah untuk soalan macam ni?
25 markah per 100. 1/4 lah, 10 markah per 40.
Oh my god.
Oh my god.
Banyak.
Zaim. Tiba. Oh my god. Famous lah soalan ni. Selalu student tak boleh jawab. Sebab dia banyak benda nak kira. Tapi usually kalau final exam face to face, ada formula, okay. Ada formula ni dia bagi formula for breakaway breaking points, formula for apa tadi, formula for asymptote dia bagi, and then also formula for angle of departure arrival. Tapi kalau tak faham formula tak boleh buat juga. Selalunya tak faham formula lah. Kalau formula dia tak ada description, so tu je lah problem. Dan selalunya soalan root locus dia akan start dengan block diagram. So you need to simplify block diagram dulu. Lepas simplify baru sketch root locus. So mostly student dah salah dekat simplify block diagram. So salah sana, root locus salah lah. Selalunya salah sampai habis.
Soalnya block diagram
Ya?
susah agak
Block diagram macam yang kita punya mock test tu, kena ada pick off point. Mesti ada pick off point ataupun summing junction. So bila korang dah salah konsep dekat pick off point summing junction, usually salah dah sampai habis. Usually rendah daripada separuh, tak dapat separuh pun.
Dia
Macam sorry?
Makan turutan
Dia macam markah urutan lah, tapi saya selalu bagi je markah kesian sikit-sikit.
Okay.
Okay. Okay. Example. Okay, so mana yang ada before we go into exercise, ni take home quiz. So take home quiz ni past year 2018-19, okay. Ni lah soalan yang student tak boleh jawab tu. Tapi ada lagi soalan lain. So deadline dia minggu depan, okay. Minggu depan Ahad. So bukan minggu ni, jangan gelabah lah, okay. So minggu depan hari Ahad. Rasanya dalam slide tak payah, relax lah. So dalam slide dekat group dah ada rasanya saya letak. Okay, so tak payah gelabah cari pasir. Okay, so kita tengok. Okay, so untuk quiz korang yang quiz 12 tu, soalan tu ada dalam slide 4C. Okay, rasanya saya bagi dalam group WhatsApp juga. Okay, soalan 4C. So try buat sendiri untuk quiz tu. try tengok jawapan dia sebab rasanya ada step by step juga tu kalau seingat saya lah. Okay, tapi kita akan try discuss soalan yang ni, example ni. Okay, so example in this slide. Okay. Damn it. Okay, dah balik. Okay, so kita discuss soalan ni. Okay, so sketch the root locus for the system below. Okay, most of the time kalau soalan exam dia akan beritahu lah kena cari apa dalam root locus tu. Sometimes dia akan beritahu cari breakaway points, cari dia punya apa tadi, asymptote, angle of departure. Sometimes dia tak beritahu tapi most of the time dia akan beritahu soalan akan beritahu to find what, to determine angle of departure semua-semua tu. Last kali baru dia suruh sketch, okay? Lepas dah cari semua yang ikut rules tadi. Jaranglah ada soalan suruh sketch the root locus without finding anything, macam clueless. Jarang soalan macam tu. Selalunya dia suruh cari dulu. Okay, so ni example je. So example ni macam clueless lah, okay? Example je pun namanya. Okay, so the first step you need to do is to simplify the block diagram, okay? So you can find the transfer function, the closed loop transfer function. S plus 4. Okay, and then simplify the transfer function. Oh my god, susahnya. Betul ke? Okay. And then from here, then you determine the poles and zeros. Okay, so the first step is always determine poles and zero. Okay, so since this is not unity feedback, so you tak boleh determine poles from from GS. You need to determine poles by substituting K equals 0 and K infinity. So here, poles at K infinity, at K0 equals S. Okay, kita bagi poles equals -2, -4 and -5. Okay, basically bila K0, kita cari yang ni je. And then zeros at K infinity. So when K infinity, kita kira yang ni je. Okay. So the zeros are -1 and -3. Okay, so since you have more poles than zeros, so you have 3 poles and 2 zeros, so you need to add one more zero, okay, so that to make them equal in number. So another one is at infinity, okay. And then kita sketch dulu poles and zero ni dekat S plane. Ui, sengit. S plane buat besar-besar. So masa sketch root locus tu, sketch lah besar-besar Janganlah sketch halus benar. Halus tu bagi kosong je. Okay. So ni JW. And this is sigma, okay. So the first one is at first kita sketch dia punya poles dulu. So -2, -4, alah. Okay, so satu poles dekat -2, another one is at -4, another one is at -5. And then 0 at -1 and -3. Okay, so kita guna X untuk poles, bulatan or circle, for 0. Okay, so the first step is to find the poles and 0 and sketch on S-plane. Kalau macam ni dapat 2 markah, okay. Selalunya student dia cari poles dia tak sketch dia punya poles and zeros, okay. So belum lukis root locus dah dapat 2 markah. Best tak? Okay, the second step is to look for asymptote, okay. So second step, asymptote. Macam mana dia punya locus? Apa-apalah. Okay, asymptote. So the formula for sigma A is apa tadi? Sum of poles minus sum of 0 divided by number of poles minus number of 0. Okay, so poles kita ialah -2, -4, -5, minus 0, so -1, -3 divided by ada 3 poles minus 1 0, 2 0, sorry. So kita akan dapat -11 plus 4 over 1. Kita dapat -7. Betul ke ni? So kita boleh sketch asymptote kita. So ni kita punya sigma, okay. Sigma kita, sigma A at -7. Okay, whatever. And then we find theta A, the sigma angle, the asymptote angle. So asymptote angle is 2k plus 1 times pi over number of poles minus number of zero. So kita start dengan k sama dengan kosong dulu. So when k equals 0, your theta A is pi. Okay. And then k equals 1. So you get theta A equals 3 pi. 3 pi maksudnya ni tak payah ambil. So kita ambil yang ni je. Sebab ni dah lebih dari 2 pi. Okay. So kita punya angle is at 180 degree. So 180 degree maksudnya asymptote tu dekat real axis. So kalau asymptote dekat real axis, sama macam tak ada asymptote lah, okay. Maksudnya asymptote tu yang saya cakap tadi, kalau dekat real axis, if the asymptote is on real axis, it can be like somehow negligible because the root locus will cross the real axis, okay. Kalau asymptote macam ada sudut ke, yang tu maksudnya root locus will not cross the asymptote, okay. So kita bazir je cari asymptote ni. Okay, and then the next step is to find the breakaway and breaking points, okay. So breakaway, breaking points, the formula is summation of 1 over sigma minus 0 equals summation of 1 over sigma minus poles. So we have 1 over sigma plus 1, okay, minus 1. So yang first 0 is minus 1 and the second one is minus 3. So plus 1 over sigma plus 3 equals 1 over sigma plus 2. Okay, plus 2, minus 2, and then minus 4 and minus 5. So plus 1 over sigma plus 4 plus 1 over sigma plus 5. Okay, and then simplify. Macam mana nak simplify ni? So darab simplify fraction, okay. Simplify fraction, you get sigma plus 3 plus sigma plus 1 over sigma plus 1 times sigma plus 3 equals sigma plus 4, sigma plus 5 plus sigma plus 2, sigma plus 5 plus sigma plus 2, sigma plus 4 divided by sigma plus 2, sigma plus 4 times sigma plus 5. Okay, kira slow-slow, nanti pening. Kita simplifykan yang atas dulu. So you get 2 sigma plus 4 times this whole thing. It equals, this one you get sigma square plus 9 sigma plus 20, sigma square plus 7 sigma plus 10, sigma square plus 6 sigma plus 8. Okay, simplify kan, you get 3 sigma square plus 9, 7, 6, 13, 22 , 6 sigma plus 8 plus 8 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 plus 38 times this one, okay. Gunalah calculator. InsyaAllah banyaknya. So, yang ni kita akan dapat 2 sigma square plus 8 sigma plus 8. Ni kita dapat sigma square plus 9 sigma plus 20. So this one 3 sigma square okay, simplifykan lagi. Equals okay, dan susun bagi simplifykan lagi. So ni dengan ni jadi sigma kuasa 4 18, 8, 12, 22. So 44 tolak 26, 18 sigma cube 40, 72, 8 dan okay, dah tak boleh dah, otak jam, kira pakai calculator. Dapat kuadratik kuasa 4, form polinomial kuasa 4. Okey, polinomial kuasa 4 macam mana nak simplify kan? Kita ada calculator. So, macam mana buat lupa dah. Okey, tak boleh simplify. Macam mana nak buat ni? Okay, tunggu jap, calculator tengah kira. Oh no. Tak dapat jawapan. Okay, sementara tunggu calculator mengira. So, kita tahu bahawa there is no complex poles and zero. So, there is no angle of departure and angle of arrival. Okay. So, we have all the necessary information. So, to sketch the root locus, you need to know the break-even points. Okay, break-even points tengah kira. Okay, JW axis crossing belum cari lagi. So, kita try cari JW axis crossing. Okay, so number 4 is JW crossing. Okay, so we take the denominator. So denominator equals, so back to here. Okay, so denominator is s plus 4, s plus 5, s plus 2, plus k, s plus 1, s plus 3. Okay, simplify first. So you will get s squared, so s cubed plus 7s squared, 4s squared, 11s squared plus 40 kan 17s plus 40 plus k s squared plus 4s 4ks plus 3k, and then you simplify further, so you get s cubed plus 11 plus k s squared plus 17 plus 4k plus 40 plus 3k. Okay, and then you do the Raut-Hurwitz table. So you start with s cubed, then followed by s square. Then alternatingly fill the two top rows. So you get 1, 11 plus k, 17 plus 4, 4k, 40 plus 33k. And then determine S1. So for S1 you get determinant of 1, 1, 11 plus k, 17 plus 4k, 40 plus 3k divided by 11 plus k. So you get 17 plus 4k times 11 plus k minus 40 plus 3k over 11 plus k. And this one is 0. And for the row S0, you get 40 plus 3k. Okay, so you look at the row S1. So look at S1 and find the value of k when this is 0. So you get 17 plus 4k times 11 plus k minus 40 plus 3k equals 0. Simplify. So you get 4k square plus 17 times 11 61k minus 40 minus 3k. Susun balik. Okay, and then you try to find k. You want positive value of k. Oh, salah kira. Lecturer pun salah kira. Tak dapat. Dang it. Harap maaf kerana tak dapat kira. Alamak, salah. Macam ni lah kot masa exam. Saya bayangkan student bila kira separuh then tak dapat, then give up. Kalau saya pun give up juga. Okay, so masa pun dah nak habis sebenarnya. Tak apa sebab we will continue more next week on root locus. Okay, but what I need you to do is to try quiz. Okay, quiz your quiz. The answer is already in lecture 4C, in the slide 4C. Try to understand how to apply the rules for root locus, and then try to submit by this week. And next week we will discuss the answer for quiz, and we will discuss this sheet, okay, yang tak dapat kira ni. And we will go into more about more example on root locus, and from there we will more understand more. Okay, so sorry about cannot finish the calculation here. I tried but tak boleh. Okay, but I will show this calculation lepas dah buat yang betul next week. Okay, so that's it for today's class. Sorry about this. Okay, so itu saja untuk minggu ni. Any question? Okay, so kalau tak ada soalan, that's it. Assalamualaikum and bye.